Good morning, good afternoon, good evening. To me, it's a pleasure to be here to talk about education in astronomy and quality using inexpensive, low-cost, low-tech materials and resources. First of all, I would like to give my thanks to the chair and organizing committee of the session for the invitation. As you know, astronomy is the oldest discipline to which human beings dedicated time in a systematic way. From the past to the present, the knowledge grew, but also the technological needs of the astronomers in order to reach their objectives, to understand the functioning of the cosmos. Methodology in education is fundamental at the time to transmit the concepts, old and new, in our discipline. The organization of the human knowledge started with the first steps, trying to understand the functioning of the skies, the movement of the stars, until now, when we are proposing a standard model to explain the origin, evolution, and possible future scenarios for the universe. One question that we can make ourselves and the teacher can ask is about the teaching of the astronomical concepts. This activity is only possible using new technologies, or it is possible to teach high quality astronomy at low cost with inexpensive, low-tech materials. But what really means low-tech or inexpensive in a world where the technology is dominant, but in general has no sense for the most part of the people? Permit me to present two big ideas. The first one is connected with the understanding of the contents, of the concepts. And we propose that to understand big discoveries with low technology and low cost resources and materials is possible. This is the base of the proposal of low-tech astronomy. The second big idea is about the discussion that should be about the teaching practice itself and the impact of that way to educate the new generations. We propose now to make an approach based on this kind of ideas about how to teach astronomy using a few topics, simple ideas in astronomy or astronomical contents through some examples to help to understand what we say when we propose a low-tech, low-cost activities. And the first example will be connected with the electromagnetic spectrum beyond the visible, the radiation, the electromagnetic radiation beyond the visible. And the activity will be connected with the detection of radio waves. Let's see. To detect radio waves, we just need a battery, two cables, and the right detector. In this case, a radio. We attach the cables to the battery, the 9 volts battery, and we turn on the radio in AM station. Not in the signal, but outside any broadcast. We produce the signal is transmitted at the speed of light, detected by the radio, and transformed first in electricity and in the second stage into sound. This device permits also to read the frequency and calculate the wavelength of the signal produced in electromagnetic waves. After the detection of radio waves in the classroom, the second example and proposal is trying to explain the Hubble-Lemaitre law, the relationship between the velocity and the distances of the galaxies. But before to explain that, we need to introduce some concepts in astronomy and astrophysics, of course. Let's see. To teach how the astronomers demonstrate that the universe is expanding, you need the spectrum. You need to show that the spectrum presents lines, and the lines change of the position if the object which produces the light is moving. You need to teach about the Doppler effect, and for that you just need a signal, for example this, the sound, and make this movement. And of course, you need to show how the light is changing because the expansion of the universe, and the photons are traveling through the universe, expanding, and the wavelength change along the time. But to explain how the galaxies are moving in relationship with the distance, it means how the galaxies moving faster if they are farther away, you just need elastic band, a rule, and a pen. That is all. And now, with the rule, the elastic band, and the pen, we can produce this kind of experiment. We put the rule and the elastic band on the table, and we mark the position of 4 galaxies. Galaxy number 1, 2, 3, and 4. And stretch the elastic band until the galaxy 1 goes to number 2. 1 to 2. And with this, we produce a table. Remember that we have 4 galaxies in position 1, 2, 3, and 4. So we can make the following. In the table, we indicate the initial position, 1, 2, 3, and 4. But the final position, when we stretch the elastic band, is 2 for the galaxy 1. But for the galaxy 2 is 4. And for galaxy 3 is 6. And for galaxy 4 is 8. This is visible on the elastic band, comparing with the initial position. So you have the initial and final position in an expanding universe. Now we can determine the distance covered by each galaxy in the expanding universe, and the expansion was all at the same time. For example, 1 second is the same. The distance in centimeters and the time in seconds. And with these 2 quantities, we can calculate the velocity. For the galaxy 1 is 1 centimeters per second. For galaxy 2, 2 centimeters per second. For galaxy 3, 3. And for galaxy 4, 4 centimeters per second. So, farther, faster. And you prove what you can measure in your spectrum. And you can show how to determine the Hubble-Lemaitre law. So, after these 2 examples, let's evaluate the activities, testing the perception or the satisfaction of the participants in this kind of proposals. Here, a few results of the satisfaction surveys. It's about the utility, the methodology, and the activity itself. It means workshops or conferences or everything. And you can see that the satisfaction and the perception of the participants in this kind of proposals is very high. The satisfaction is so high that they use a lot of this kind of materials, low cost, low tech, and we also evaluate what happened with the impact in the classroom. And to know that, we use some kind of forms to evaluate the evidence of use, to have the evidence of use and application of the contents. And each year we receive hundreds of evidences of use of these materials. Now, evidently, we need to revise our own and previous ideas about the teaching of the astronomy. And the question will be, the high-tech and high-cost technology is really a need at the time to transmit astronomical concepts in the classroom? Yes, no, I don't know. What is your answer? My answer is no. It is no needed. And in this way, we arrive to the first conclusion. The low-cost, low-tech tools and resources are not correlated with low quality in education of astronomy. On the contrary, you can teach very high-level concepts in astronomy using low-tech resources. The second conclusion is about the level of this kind of proposal, where using different approaches and upgrading the contents with the times, this proposal is not only for primary, secondary, and high school classes. It's also very useful for the first steps at the colleges. And as final remarks, we can say that the methodology based on learning by doing first, hands-on activities, using low-tech, low-cost materials helps to understand the basic concepts and contents. Of course, we need to start from the basis, but produce a perdurable knowledge. Learning by doing is the best way to understand and remember and understand really the concepts. On the other hand, helps to face more complex topics and assure the inclusion, mainly for economically disadvantaged countries and audiences, and of course, much more. That is all. I hope you adopt this kind of methodology. Thank you very much for your attention.